In applications where your generator is smaller than your utility service, you essentially have three options: buy a bigger generator, use a typical sub-panel installation, or utilize the common zone and load management system. This option gives the homeowner more flexibility, reduces installation cost, and allows you to use a smaller generator than either of the other two options. It allows you to turn off the non-essential high-current devices such as air conditioning, hot tubs, or electric heat. Turning off these high-current devices allows a homeowner to continue to operate the essential loads inside the home. The generator has two load management controls, LC1 and LC2. In this example, air conditioner 1 is controlled by LC1 and air conditioner 2 is controlled by LC2. The utility power has just failed. The generator starts and is now powering the home. At this time, LC1 and LC2 are off. After a 3-minute delay, AC1 is allowed to turn on since the home load is below 70%. After another 3-minute delay, AC2 is allowed to turn on since the load is still below 70%. As long as the load level stays below 95%, the home and both air conditioners will be powered. When the load level exceeds 95%, both air conditioners are turned off by the load management system. Once the load level goes below 50% for an additional 3 minutes, AC1 will turn on. The load level is below 50% for an additional 3 minutes, AC2 will turn on. As long as the load level stays below 95%, both loads will remain on. If the load level goes above 95%, the load management system will disable both AC1 and AC2 for the duration of the power outage, unless reset by the homeowner. This is to ensure that the homeowner-designated essential devices will remain powered without overloading the generator. It is important to review with the homeowner which loads are essential during a power outage. High output, non-essential loads can be connected to LC1 and LC2. Take time to carefully discuss with the homeowner the many options for load designation. To connect, run wires from the transfer switch terminal block to each load that will be controlled by the common zone and load management system. Connect a relay to each load in one of two ways: low voltage or high voltage. For devices that are controlled by a low voltage signal, like an air conditioner thermostat, installation of the relay is accomplished as follows. Connect the relay to the control signal wire between the thermostat and the air conditioner. In this application, we're using a single pole double throw relay capable of 1 amp at 24 volts AC. This relay should be wired normally closed. In a high voltage situation, use the relay to cut the actual power to the load instead of just the low voltage control wire. For 120 volt relay, use a single pole double throw relay, sized for the actual load and wired normally closed. For a 240 volt relay, use a double pole double throw relay, sized to the actual load and wired normally closed.